Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our on-demand content. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Now let's get started.
Hello, welcome to the AI 900 certification program, Artificial Intelligence Fundamentals by Human in Azure AI. I am Jacqueline Ramos and I am part of Human in Azure AI leadership team. This program was created by the Homemakers Code and the Tech Human community in collaboration with Microsoft experts. It is open to the entire community to learn the fundamentals of artificial intelligence, chatbots, machine learning, and generative AI. The program includes 8 live classes, completely free in English, and required proof of participation at the end of the program. Requirements for proof of attendance. To receive your certificate, follow 2 steps. First, attend the live classes or watch the recordings between May 60 and 29. Second, complete the Keynote texts until May 31. A week after the second class, you have access to a quiz to reinforce what you have learned. When did you earn the AI 900 certification? There are additional 30 steps. Complete the Cloud Skills Challenge before May 31. You have access to a free Microsoft Learning Path with hands-on AI labs. The 100 most committed students, you received a voucher for the AI 900 certification free of charge. Good luck with your studies. See you soon.
Hello, everyone, and welcome to this session of the Women in Azure AI for the AI 900 program. So we are here to learn about AI, and specifically, we are here to learn about vision, artificial vision and visual computer search. So let me introduce myself. Hello, everybody. I'm Laura Núñez, and I'm a Microsoft technical trainer based in Spain. So you have here my LinkedIn in case you want to reach out. And just to tell you a little bit about me, I typically dedicate my time here at Microsoft to all the Azure portfolio related to either administration, architecture, networking, and also AI engineering. So yeah, hello, everyone. And also, hello to our moderators that are going to be helping us on the chat, answering all your questions. So welcome also Natalia, Camila, and Gabriela. Thank you so much. Also, you can reach them out on LinkedIn if you want to keep the contact. So welcome, everybody, and thank you. What else? Okay, so just so you know, this is part of a program, so you can keep learning. You can keep learning about different things in Azure AI by using this learning path that we have prepared here, where you can have study path, so you can keep learning for certification. You have practical labs, and you can also have access to a certificate of participation. So you have the URL. And you can also scan this QR code. I'm going to give you a couple of seconds so you have the time. Okay, so what are we gonna learn today? We are gonna learn about the computer vision basics and what can we do with the computer vision service that we have in Azure. We are gonna learn about facial recognition, so the options we have to recognize faces, and also how can we recognize text. So how can we extract text from images? That's the agenda for today. Let's start with the computer vision basics. So, where is all this coming from and how does it work? And for that, I would like to all understand what is an image? What is an image for a computer? How does it actually look like when it's a computer who's looking at them, right? An image is basically an array of numerical values of pixels. So it's divided into small, different squares, which are just numbers, pixels, okay? If the image is going to be black and white, we are going to have an array like this. It's made of zeros and it's made of 255. Okay, so black for the zero and 255 when the pixels are white. And with that, we have an image. But if we want the image to be in color, right? Sorry. So if we want the image to be in color, what we actually have is a multi-dimensional image. We are going to have three different arrays composing our image, one for the red, one for the green, one for the blue. And we are going to have numerical values on each of the pixels representing the amount of red, the amount of green, and the amount of blue that we have on each pixel, which is going to make the end color, right? So basically, when we combine the red, the green, and the blue, we can have something like this, a combination of colors which makes maybe purple and maybe yellow, right? So that's actually an image, a representation of numbers. So what do we do when we want to modify an image or when we want to find information about an image? What we are going to be doing is we are going to be applying a filter. And what is a filter? It's also going to be an array with values that when it's applied to the image, it's going to change the value of the pixel that it's on top of, right? So something like we can see on this left image. So when we are using filters to process the image and we apply it and we go pixel by pixel, we are doing something that basically it's called convoluting, which makes a convolutional filtering. Why is that important? Because convolutional is going to be a word that we are going to be using later. So when we do this convolutional filtering and we do it over all of the image, we are going to be changing the image in a way that maybe can help us find out information about the image. Like for example, if we apply this plus filter, as you can see, we can find the contours of the image. So we have a banana and we can see where the banana starts and finishes thanks to this filter, right? Okay, so now that we understand this, let's go for convolutional neural networks. What is this? This is super important for vision recognition and vision classification and object recognition and all of that, because it's one of the most used type of models for these use cases. So what is gonna be happening here? Okay, remember, our images are numerical representations of different pixels. If we apply a filter or several filters on top of them, we are going to be able to find and to extract the features, like the color they have, like the contours they have. We are going to be able to find out information about what's inside of the image. If we combine all the features that we can extract from each image and we put that as an input into a neural network, which is this kind of thing, okay? Basically, we're going to be able to do things like, for example, classification. Thanks to the features we can recognize on each image, we are going to be able to find out, well, the neural network is going to be able to find out, based on the features, if the image is a banana, if it's an orange, or if it's an apple, because it's containing more features of an apple than of a banana, for example, right? So that's how convolutional neural networks work. Now, another thing we need to understand in order to understand computer vision is transformers. What do we do when we have when what we have is text instead of images? Well, we are going to be using another kind of models that are called transformers that are going to be able to transform the words into also numerical representations, which are going to be called vectors or tokens. So these tokens are going to be related to each other depending on how semantically similar they are. So banana is going to be more similar to fruit than to dog, for example, right? Or a skateboard is not going to be related to orange or to apple, right? So if they are more similar, they are going to be closer. So we have numerical representations of images, and we have numerical representations, encodings of text. We can do that with these two kind of models. What else do we have here? We have multimodal models, and this is the coolest thing ever, right? Because we can combine the encoding of the text, so converting text into numbers, into vectors, tokens, and converting images into also numerical representations, so numerical features. We can combine both of them into models that are going to be able, based on that, to take an image and find out what's in the image. So, okay, this is an apple, this is a banana, this is an orange, or this is fruit in general, right? To find out where in the image we have the banana, where in the image we have the orange, where in the image we have the apple. So that will be object detection, right? It's also going to be able to, and this is really cool, to generate a text out of the image to describe it, subtitle of the image. Like, for example, if we have the picture of a banana, it will say a banana. If we have the picture of an apple, we will have the tag or the subtitle, the caption actually, of an apple, right? And also, out of an image, we can we can generate tags that describes the image. So, for example, if we have a picture of several fruits, we can have tags that describes the image, like fruits, banana, apple, orange, um, I don't know, a basket maybe if it's showing up on the picture, right? So we can have descriptions of what we have inside the picture. So we can do a lot of things with these multimodal models, right? And the really, really cool thing is that the Florence model, for example, that we use here at Microsoft for these kind of tasks, is something that we can adapt and we can customize. So it recognizes our own objects, it recognizes or it classifies according to our own classification tags. We are going to talk about this later, but they are adaptable. So it's really, really cool. Okay. So if we understand now what we can do, where it's coming from, what we can do with the images, now let's see how we can actually do it by using Azure. And we are going to be using here two different things. We are going to be using Azure AI Vision service, and we are going to be using Face, which is going to be related with faces. Makes sense, right? Because of the name. So what are we going to be using Azure AI Vision for? We are going to be using it for image analysis, like recognizing characters on a text, so reading what's on the text of the image, generating captions and descriptions, detecting objects inside the image, generating the tags we were talking about. So you have the image and then generating tags to describe the image. Also, we are going to see that with Vision, we can customize these models for image classification and object detection. And when what we want to recognize or what we want to detect are faces, we are going to be using this other service, which is called Face. Okay, so we are going to be talking about these different things today, and I'm going to show you also a quick demo of some of them. Cool, so let's go ahead with the very first task that we can perform, which is image analysis. Let's understand what we can do with related with image analysis. Okay, so we take a picture, and with the image analysis capabilities of AI Vision services, we can customize the models. We can read text from the images, but in a really basic way. We are going to see that we have a more complex way later, so with more rich results. We can detect people in images. So here there's a person. I don't know who it is, but there's a person in here. We can subtitle the image, so generate a caption. We can detect objects in the picture. So there's an apple here. And well, we can generate tags, and we can even crop it so we only show the most interesting region of the picture. So we can do this kind of things, okay, with image analysis AI vision. So, sorry. So if we decide to do any of these features, we don't need to train the model. We can use the image analysis models as they are. We just use the service, and we are going to be able to do all of this. We don't need to customize it, right? But we have the possibility to train it by providing a lot of training data to customize them so they can recognize, for example, the objects that we want, not all the objects possible, but only the objects that we want. So it could be, for example, different products on a shelf on a supermarket, or it could be I don't know, different items on a factory that we are manufacturing, right? So it could be recognizing our own objects, and also we can use it to classify according to our own classes. So our classes could be apple, banana, orange, or it could be product A, product B, or product C, or it could be broken, not broken, or something like that, right? So we can classify it. If we want to do that, we will see that we will need to train the models. Okay, so it's not going to be out of the box. We need to train it a little bit so it knows what it is doing. Okay, and what about, oh, sorry, just one second. Oh, come on, yes. What about seeing some of these things actually working, right? So we said that when we have a picture, when we use our vision service, we have a picture and we can generate a description of the picture. So for example, I have this one. And automatically the model is going to be able to say, hey, this is a man jumping on a skateboard. And what about this? This is a man holding a surfboard on a rock. Oh, okay, and what is this? This is a group of cows grazing in a field. So this is generating a caption given a picture. I just give the picture and it's generating text. Do you remember how are we going to be able to do this? Because we are using the multimodal models, right? Okay. Then what if we want to detect objects inside an image? Well, the models, without training, the models are going to be able to do it. So we can provide a picture like this one. And what are we going to get in return? We are going to get the objects that it's able to detect. Like, for example, this is a person, this is a person, this is a person, but this here is a laptop. Oops, let me show you the laptop. Here, this one, here, laptop. This is a sitting. This is a sitting too. What is this? This is a table, right? Looks like a table. Yes, it's a table. Or even footwear. Okay, so we provide a picture and we are going to be receiving the objects that are detected. But also, we are going to be receiving back from the model where the objects are located. So we are going to get a bounding box. And that's really cool, right? Because we can locate the objects in the picture. And we are going to be able to, for example, draw something like we are drawing here, a square around them. So we are going to receive these coordinates. Also, if you see, we have here some percentages. So can you guess what it is? Well, let me tell you. Basically, this is the confidence that the model has on being right about finding out that that's a person, for example. So this is a 76%, 76.5% sure that this is a person, this one here. Okay, so we are going to be receiving a lot of information about the things that the model can detect on the image. If we go, for example, and provide a blurry image like this one, okay, the models still really work pretty well, and it can detect that this is a person, and this is a subway train. Maybe the confidence may be a little bit affected. It will be better if the picture is not blurry, but it works. So modern models are working really, really good. And well, for example, here it's a simple image, but we have the person here and the skateboard here with a lot of confidence. This is 95% and 90%. Okay, so pretty confident about that. Okay, so these are some of the things that we can do to recognize things on the images, right? Generate captions, we can find out objects, We can generate tags. Now let's talk about, let me go back to my slides. Here, let's talk about what we can do regarding facial recognition. So for this, we are going to be working on faces, okay? We are going to be trying to not only finding out if there's a person on the image, we are going to be trying to find out if there's a human face in the picture, and also some information about the human face. So we are going to be trying to find out, okay, the bounding box of the face, so where is the face, but also some facial features like where are the eyes, where is the mouth starting, and where is the mouth finishing, if they are wearing a mask or if they are wearing glasses, and what type of glasses, so we can find out those kind of things. Also with this kind of service, so with face, we can use you can use it only not only to we can also sorry we can use it also not only to find out if there's a face in there and how is the face looking like. We can use it for facial recognition, so to identify who the face is belonging to, or if the face is the same one as another one we have, right? But there's something we need to understand here. When we want to use these facial recognition capabilities, we are using sensitive information, very sensitive information. It's identities of people. So we need to commit, in order to use this, we need to commit to the responsible AI principles. So we need to make sure we are applying the responsible practices, so people is informed of how we are using and for how long we are using their information and their faces. Okay, they need to know that they are being recorded, for example, or that we are storing their information. And in order to have access to this kind of service, we need to apply for access to Microsoft. Okay, so it's going to be Microsoft allowing us the access to these features, but as long as we are compliant with everything, we should be able to use it. And it's going to be useful in a lot of use cases, right? Like for example, for security, or for example, to find people that is lost. So imagine this use case where I don't know, a kid is lost in a supermarket or a train station. We can find it, right, by using the cameras. So the kid is found like super easily and super fast, and we avoid a such situation. So we can use it for people's security. We can use it for really, really, really good and cool things. Okay, but we need to be careful on how we are using this information. So when we are using the face service, then what can we find out about the faces? First, well, we can find out where is the face, like you can see here, what's the bounding box of the face. We can find out what's the head position. We can find out if it's occluded by something, like if it's wearing a mask, if it's wearing glasses, if the glasses are sunglasses or they are reading glasses. We can see also if there's some noise, maybe over the image, and maybe the image is not going to be super recognizable. We can also find out exposition of the image. We can find out if it's blurred. We can find out some information about the face to see if the face is going to be seen properly, right? And yes, if we want to find out if the face is looking like another face, or if the face is actually looking like a certain person, we need to have Microsoft approval. Okay, so let me go here and show you a little bit how this will work with faces. So we have here, for example, this image, right? So we provide this image. Now, because we are using the face, models instead of the vision models, we are going to be able to not only find out if there's a person, we find the face number one and face number two. But look at the other information that the model is giving me. The model is telling me, I don't know if you can see the small white dots that we have around the mouth, around the eyes, around the nose, around the brows, so we can see where they are located. So with that, we can find out a lot of things about the faces. Are they smiling? Are they sad? Are they worried? Is there something happening, right? So we can find out information by having the landmarks. Also, you can see here that this is telling me if they are wearing a face mask. The answer is no, none of them is wearing a face mask. But if we go to this picture, okay, we find one of the faces, we find the landmarks, and we see that the face mask is covering the nose and the mouth. So it's telling us how occluded it is. If we go for this other picture, there is a mask, but the model is not confused. The model says that the person is not wearing a mask. Okay, so we can find this kind of information. We could also be asking the model, in this case, in this example, we are not, but we could also be asking the model, like, is this person or is this face wearing glasses, and what type of glasses, right? So sunglasses, reading glasses, so those kind of things. Okay, so coming back to the slides. Basically, how is this actually working in the background? So how is the facial recognition working when we want to compare it to some other faces? Well, first, we need the image to be captured. So either pictures or maybe frames of a video, right? So we need the image to be captured. Then it's gonna go through the model who's gonna read, so who's gonna extract the geometry of the face, so these facial landmarks. So what's the distance maybe between the eyes? What's the distance between the eyebrows and the position? What's the size of the nose? What's the size of the cheeks, of the mouth? So it's gonna be creating a facial template of that face. Okay, then that facial template is going to be compared to a database that we have, that we should be having, of different faces that we want to compare it to. So, for example, if they want to recognize me, they need to have a database of my face. Okay, so different pictures maybe of me, like maybe on this position, maybe on this other, maybe looking up, maybe looking down with the eyes closed. Well, we don't need many pictures, we just need a few of them, but we need several pictures so we can train the model with it. It's gonna be comparing the face that it found, the facial landmarks, with the database ones, and if it finds a match, then it's gonna say, "Hey, that's Laura." So it's recognized. It's recognizing me, right? So that's how it works in the background. Then another thing we can do with these services, we can recognize text. Let me tell you, we are going to have several options for this text recognition. Okay, so first of all, the most simple thing, we can use the vision service to provide a picture of any text. It could be text, handwritten text, like this post-it that we have here. It could be text, I don't know, that is showing up on a book that we took a picture from. It could be text showing up on a sign that we want to read, right? So we take the picture and then we provide it to the vision service, and it's going to be able to recognize, to extract what's the text that's written in there. It's going to be able to analyze, even if it's handwritten, it's going to be able to analyze the shape of the letters, numbers, and punctuations and other text elements, and then convert them into digital text, right? So if this wants to show, yes. So if we go here, sorry, let me show you how it will work. If we provide some text to the some images with text to the model, we are going to be receiving back the different words that are found. So you see nutrition here, facts, amount, pair, serving. We are going to be receiving that, but also same as with the object detection and same as with the faces, we are going to be able to receive where those words are located in the picture. So I know this square is surrounding amount, this square is surrounding total. So we are going to be getting all of the text that can be recognized on the image. And as you can see, this is printed text. So this it looks like a label or a tag of maybe some food, right? But what if we provide handwritten text? Okay, so you can see we have each word, but also it is sorted, right? So we can read the whole text. So we have the words, we have the sentences, and we have the whole text. So it says here in this handwritten note, it says that you must be the change you wish to see in the world. Everything has its beauty, but not everyone sees it. Okay, cool sentence. And we take a picture of this note, handwritten note, and then we can see the converted text in here, recognized. It's also going to be working for any kind of thing that we take a picture of, like, for example, credit cards, like, for example, what is this? Social security card. So, or for example, these captions that we have here on this cool picture, right? So it's going to be able to recognize no matter of the font, no matter of the size, if it's handwritten or not. But we need to understand that if we use this OCR service from Vision, it's going to be a basic way of doing it, because it's only going to be providing us with the text, right? Only the text. It's not analyzing what's in here. It's not recognizing the difference between the different things, just the text. So what can we do if we want to know more about it? Well, let me show you here back. If we want to know more about the information the information that's contained into that text, we can use this other service we have, which is document intelligence. So what is document intelligence going to be able to do? We are going to be able to provide a picture of something, but we are not going to be getting back only the recognized text. We are going to be getting back also information from that text, because document intelligence understands the layout. What do I mean? Well, if I provide an invoice, if I provide a receipt, if I provide a business card, a credit card, if I provide the social security card, for example, that we saw there, it's going to be able to understand, hey, this is the name. Hey, this is the card number. Hey, this is the address. And this is specifically the street name of the address. And this is the, sorry, this is the number of the house, or this is this is exactly this thing, or this is the number of the customer, this is the item number one we bought on this receipt. It's going to be able to identify what the text is meaning, right? So what it belongs to. It's going to be able to understand and recognize metadata out of documents, because it understands the format. And we can use it without having to train the model to do a lot of things, like, for example, document classification, and also to understand the text of business cards, invoices, receipts, contracts, ID cards. So we are going to be able to use it for several things. Also, if we want to, so same done with the Vision model, if we want to customize it and we want to train it so it understands our own document formats, not only the provided by Microsoft, but also our own document formats, we can train these models, we can customize them by providing a lot of documents, not too many, but we need at least a few, right, of each type. We provide our own document formats, we label them, we say, hey, this is the name, hey, this is the credit card number, for example, and then the model is going to be able to recognize our own document formats. So let's see how this works. I'm going to go here and I'm going to be using document intelligence. So I'm using document intelligence now to understand ID cards. For example, we have this one. It's a driver's license. As you can see, this is providing me with the text, and it's providing me with the bounding boxes. But it's going to give me even more information. This is the region. This is a first name. This is a last name. This is an address. And this is incredible. I love this. This is the vehicle classification. So it tells you what type of vehicles you can drive, right? So it understands that this A means the type of vehicle. And well, we have the height, we have the weight, we have the color of the eye, so eye colors. It's able to understand different things. And no matter the format, so if we provide a different one, for example, this one, we can run an analysis, and different colors, different sizes, we are going to still be able to get the information. So this is the last name, this is the first name, this is the date of birth. What about this social security card? We can run an analysis on that. It looks different from the ID cards that we have before, right? But this is the first name, and this is the last name, and this is the document number, and this is the date of issue. What else can we do here? So let me show you. In document intelligence, we can also use it for receipts. So we have a receipt. We bought here apparently a hot dog, a double cheeseburger, and a beer. If we run the analysis, we have, well, that this is the name of the merchant. This is the quantity of the hot dog item description. This is the quantity of the double cheeseburger. This is the quantity of the beer. This is the subtotal. These are the taxes, the tip, and the total. If we go for the picture of a real one, because that was a screenshot, right? If we go for the picture of a real one, we can still run an analysis. We have the merchant name, we have the address because it's present here. We have the quantity, we have the description of the item, we have the price of the item, we have the subtotal, the taxes, and the total. And let me see what I have here. I also have, for example, a printed one, right? So it's also going to be able to do the same. It's analyzing and getting the merchant name, and it's getting the description, and it's getting the totals. So it's going to be able to understand different things. And it's really cool because we have pre-built models for a lot of type of documents. So invoices, receipts, identity documents, insurance cards, credit cards, contracts, business cards. Like, for example, let's explore this one. What do we have here? So this is a name and this is the last name. Cool. So it's working. Perfect. So as we can see, this is a little bit different from OCR because this is only providing the text. This is telling us what the text is because it understands the layout. It gives us more information. Depending on what we need, we can use one or the other. Maybe here we don't need the other, right? Okay, so going back to the slides, let's recap a little bit what we learned. Remember that, we talked about vision services where we could provide a picture and then we were recognizing what objects were in there. We were able to also classify the picture into different categories. We were able to generate captions of them. We were able to generate tags, or we were able to, to, for example, tell a description of the image. Also, with face service, we were able to get the faces on an image, and we were able to get the facial features of it. So, where are the where the eyes located? Where is the mouth located? Where is the nose located? So, the facial landmarks. We were able to see if they were wearing masks or not, if they were wearing glasses or not. Also, what's the quality of the image, and we were able to train it so it recognizes faces. But remember, for that, we need to have the approval of Microsoft and we need to commit to the responsible AI principles. Then, if we want to recognize text, we have the possibility to just extract the text directly with OCR or with document intelligence to extract the information of that text. Okay, so with that, we have explored the different options that we have with the vision, face, and document intelligence services in Azure AI. If, as I said at the beginning, if you want to keep learning, if you want to study for a certification, if you want to have some hands-on and use the practical labs that we have, or if you want to get a certificate of participation, just make sure you visit this URL. You can scan the QR code and keep learning about AI, because we have so many wonderful topics to learn from. And you have here some contacts. Again, you have my LinkedIn. You have the LinkedIn's of the moderators. If you wanna keep in touch, we will love it. We will really, really love it. And the next session that we have is gonna be happening in actually 3 days. So the 15th of May at 12 p.m. ET time, and it's gonna be about text and language understanding, so natural language processing, how the AI is going to be able to understand from a text the meaning. That's also a really, really cool thing to learn about. So before we close, because we have time, make sure that you drop all your questions on the chat. Okay, if you have anything that you want to ask. We have our moderators there to help you. I can also answer some questions if they reach out to me. And otherwise, thank you so much. Thank you so much for attending this session. I hope you keep learning and keep researching on AI, because it's a wonderful and fun world. And yes, it's been a pleasure to have you here. Thank you, everybody.